So the other day, I was rewatching a video made by Rekrap, where he attempted to monopolize Netherworld on the lifesteal SMP. And at the around 2:30-minute mark, he showcases his graph in DESMOS, which he used to cross out structures he's already visited and predict where the next might be. And I thought, that's pretty neat, I could use that. So I searched up the URL from the video, and sure enough, it actually worked. I was able to find the original graph that Rek used. But after taking a closer look, I noticed it wasn't very optimized. The graph had fixed borders and a set number of grid lines, all of which were added manually one by one. So I decided to make an improved version, something more versatile and easier for anyone to use. In the next part, I'll explain how the Nether Fortress and Bastion generation works based on the Minecraft wiki, and also how to use my DESMOS graph. I should also mention that I will only be covering the Java edition, since Bedrock has slightly different generation mechanics. Nether Fortresses have a 40% chance to generate, while Bastions have a 60% chance. However, Bastions cannot generate in basalt deltas. If they attempt to generate there, a fortress will generate instead. These structures can spawn within a 368 by 368 block area, and only one can generate in each area. There is also a 64 block border to the east, which is positive X, and to the south, which is positive Z, where no structures can generate. This pattern repeats infinitely in all directions. To recreate this grid-like pattern, I used a simple function. It represents the remainder when dividing X by 10. X can be any number, for example, 5. If you divide it by 10, the remainder is also 5, which is then shown on the y-axis. If you reach a number like 11, the remainder becomes 1, which causes the graph to drop down and start increasing again. This creates a repeating pattern of identical rising line segments, which reset every 10 units along the x-axis. If you add a condition less than 1 to the end of the function, the remainder will be shown when it's smaller than 1. This results in the graph displaying only vertical lines at specific intervals along the x-axis. Using this, I was able to construct the full grid, which I then compared to a reference image from the Minecraft wiki. Next, I added borders. I took the border value and divided it by 2, so that half extends to the positive side and half into the negative side of the x-axis. Then I marked everything outside of these values as a border. After that, I added a table for inputting coordinates of structures you've already found. This allows you to mark explored regions and rule them out when searching for new structures. As a small bonus, I also added toggleable grid lines, which help you navigate the Nether more efficiently. If you set your render distance to 6 or higher and follow these lines, you should be able to find nearby structures fairly easily. I split each region into 2 lines instead of 1 because the Nether terrain often limits your visibility. Some notable lines include -588, -340, -156, 92, 276, and 524 on both axes. One important detail is that the graph is flipped. Normally, Minecraft tools like maps and C-finders use -Z as north. This means the y-axis in this graph is mirrored. In other words, y corresponds to -Z and -y corresponds to +Z. Rek actually used this in his video by flipping the graph and entering the structure coordinates with inverted y. And one last tip, if you're playing on a map with limited borders, like events or minigames, you should travel in the direction of -Z and +X, since this gives you the most available space for structures to generate. Both mine and Rek's original graph can be found in the description. If you guys ended up liking this video, consider leaving a like and hyping it. I'd also welcome any criticism about the video in the comments, especially if you had a hard time understanding what I was trying to convey. If I talk too fast, pronounce any words wrong, or about the editing quality in general. With that being said, have a great day and see you next time.